see how I can share. כן, בינתיים עושה. תן לי להתקשר לך עוד כמה שעות, טוב, אני פשוט מלמד עכשיו. טוב? ביי. Okay, the goal of the today's meeting is actually very straightforward, because what I want to do, I want to explain how you can actually conduct in a very straightforward manner and in a very concise manner regressions in Python. Okay, so what we want to do, we want to download stocks into Python. Then we want to calculate returns. Then from returns we want to do regressions. And then we want to basically plot and calculate residuals for our regressions. Okay, so that's the goal of the meeting today, and it will take whatever it will take. If I'll be done in half an hour, then that's it. We will do it in half an hour. Okay, so I'm going to share the code with you. This is the code, and I'm going to run it before we do anything else. You see, that's the result. Okay, so this is your this is X and Y are two stocks, and this is a regression line, and these are basically the plot, the scatter plot for these stocks. Okay, so this is a classical presentations of regressions. Okay, any questions? And here I'm giving you the slope, I'm giving you the intercept, I'm giving you the standard deviation, and I'm giving you the R2 square. Okay? So just to remind you, what we have here is basically a very simple model. It's a one-dimensional model. Okay? Where you basically have, you know, let's say you have a stock Y, and then you have X, which is your, you know, which is your whatever, which is your another stock, and then you have the model alpha plus beta X plus epsilon, where this is going to be your residual. Okay. So, for example, in the CAPM world, you have that Y equals to alpha times beta times S&P plus epsilon. And here you're doing it through returns. Okay? Extremely straightforward. Now, just to remind you, if Y equals to alpha plus beta X plus epsilon, then variance of Y equals to variance of alpha plus beta X plus epsilon. But because the variance is actually alpha is a constant, what you have here is a variance of beta x plus epsilon, which equals to variance of beta x plus 2 times the covariance of beta x and epsilon plus variance of epsilon. Now, remember that x and epsilon are independent. And hence, covariance of x epsilon equals 0. So what you have here okay, is as follows. You basically have that variance of y equals to beta square variance x plus variance epsilon. And the R square is basically the ANOVA analysis. So how much of the randomness is explained by the variance? So what you have here is as follows. R square equals to beta square variance of x divided by variance of y, which equals to beta square. Now, beta equals to covariance of xy divided by variance of x. So what you have here, you're going to have that this is going to be covariance of square xy times times variance of x, variance of x divided by variance of y. However, remember that covariance of xy, covariance square xy divided by variance of x. So it's covariance of xy divided by variance square of x times variance of x divided by variance of y. And this is going to be beta square. Okay? So you're getting here that this is going to be rho square times sigma x square times sigma y square divided by variance square of x times variance of x divided by variance of y. Okay, so variance of x and the square goes away, variance of y and this goes away, this and this goes away, so you're having that this is rho square. So this is correlation square. That's why r square is called rho r square, because this is correlation square. So correlation square dictates how much of the randomness is explained, okay, by the variance of your predictor, which is x. Okay? And in the general case, if I have y equals to alpha plus beta 1 f1 plus beta 2 f2 plus beta k fk plus epsilon, the variance of y equals to beta, the vector beta. So beta is beta 1, beta 2, beta n. So this is your vector beta. So it's beta times your factors times beta transpose plus variance of epsilon. And then the R square, in the general case, is going to be beta F beta transpose divided by variance of Y. Okay? So it's very simple. Now, what I want to do here, what we want to do, we want to understand, okay, if I have the CAPM or I have any other stock, and I have Y equals to alpha plus beta times X plus epsilon, okay, what I want to do, I want to understand how to retrieve these betas and alphas in Python. Okay, and I also want to merge it with a Yahoo download. Okay. So first of all, let's look on the regression as a standalone. Okay, so let me open the file. Okay, so this is the example what is standalone. Now, before you run it, okay, so before you run it, what you want to do, you want you want to actually import those models. So this is, we don't need this, but the ones that are important is the sklearn linear model and the matplotlib, because this enables you to plot. So Python itself is a very naked language. It has almost nothing. What is actually very powerful, okay, are those libraries. So what you want to do, you want to, if you are not using Anaconda, so in the profession, they will actually use what they call Jupyter books, Jupyter notebooks, or Spider notebooks, which is part of Anaconda. Okay, if you are inside this system, in order to bring, a lot of times Anaconda has all these libraries already. I basically don't like Anaconda at all because it requires 30 gigabyte of memory. Okay, and I don't think I need to sacrifice 30 gigabyte of memory for any development system as powerful as it is. Okay, so I'm working with a terminal. So for example, if I want to, if let's say I want to bring in matplotlib, right? So what do? I just do this command. Inside the terminal. Okay, so this is going to be inside the terminal. I remind you how to get the terminal. So if you go here, okay, if you go to your Finder or here, you will see that you have a mirror here. You see the mirror? So in a Mac, you just press on it and you type terminal, and the terminal will appear. Okay? And I'm not restarting my terminal. So I have only one terminal, and I'm not restarting it. So it's actually very convenient for me to do those commands. So my command is pip install matplotlib, and you see that it actually installs matplotlib. Okay? And if you want to install pip, somewhere here, I told you how to install pip. Here, this one. This command. And then you, after you do that, then you type in this. Okay? And then you can do pip, you can install any package you want from the terminal. So here, I'm installing the package which is called matplotlib. So the command is always pip install and the name of the package. Pip, not Russian, English. Pip install and the name of the package. Okay? So we are now looking on regression as a standalone before we embark here. All right, so here I'm the first thing I'm doing, I'm importing my numerical the numerical Python library numpy. This is basically the engine of all the libraries that we have in the numerical libraries that we have in R. Then we do from SKA learn linear model, we import linear regression, and then we import the plot. Okay, so the first thing I'm doing, I'm defining my two vectors x, and I'm defining my vector y. I'm defining them as np.array. So we discussed it last time that you have usual arrays in R, but you have np arrays in R. Okay, so this np is abbreviation for numpy. So if I wanted to say it without np, I would say something like numpy dot array, and then I would define my array here. Okay? All right, so now what I'm doing, I'm defining my x and I'm defining my y, and I'm doing a reshaping for my x. Okay, lucky for us, when we will look on Python from Yahoo, we won't have to do it. Okay, and here I'm doing linear regression. I'm deploying my model, which is my linear regression model. Okay, so when I'm going to run it, when I'm going to run this example, okay, okay, so these are your points, and this is your regression line. And if you go on this line, you can see its coordinates. Okay, so you immediately see that 1625 and 1437 are on this line. Okay, so here you can see that the intercept is given by model intercept underscore. So this is a property of the model. okay? And you can do a prediction. So here, my y underscore predict is basically model predict x. So if I will do something like that now, say, for example, model dot predict 6. Okay, it's not defined. All right. Let's see here. Let's say I do model dot predict he wants to use an array, so maybe np dot array 7 or something like that should do the trick. Now, okay, we'll talk about this a little bit later. Oops, sorry. Okay, so this predict here that you see, this model predict takes x, okay, takes this x and makes the prediction for y predict. So if I will say x now, let's say z now equals to np dot array, let's say I'm going to give here two different numbers like 1, 2, 1, 3, and 7, and then I'll do a reshape. Okay. And then I'll do a reshape, and then I'll do model predict Z. It should work now. Hopefully it will work, okay? Another one. Okay. So you see, it actually printed the predictions for these three numbers, 1, 3, and 7. So if I look on the intercept, this is going to give me the alpha. So print intercept is going to give me the alpha. So the alpha is 5, 6, 3, 3, 3, 3. Alpha is 564. Okay? And I can also get the slope. Oh, sorry. So it's model dot slope. Okay, so if we do something like that, we can always say linear regression Python attributes and if we want to see the model coef. Okay, so the model coef is 0.54. So if I will take 0.54 times, let's say 1, plus, and then I'm going to add to it the intercept, which is this, I can think about my prediction being 617, which is exactly the number that I got here when I use the function model predict. Is this clear? So model intercept underscore gives me this the intercept, the alpha of the regression. And model dot coef underscore gives me the beta of the regression. So if I look on beta times some number s plus alpha, this is going to be my prediction. Okay? Now, if I want to get the R square, okay, this is going to be called model.score, model.score underscore. Let me just also give you this page if you want to expand your knowledge later. Okay. Just close this. I think we can close this. We can close this, close this. Okay. And I think we can minimize this. Okay? So model score This is your R square. Okay. So if I'll put here, okay, so every time it runs, so let me just close this because these windows are redundant. Every time it runs, you see it runs in a certain shell. Okay. So in this case, if you do model.score, it will show you the R square, which is 0.71% or 71%. Okay. So if you want this in you have this. So the R square is 71%. Okay? Questions?
Professor, what is R square scores?
Can you repeat the question? I didn't hear you, sorry.
What is R square scores?
No, the R square, okay, is actually explaining how much of your variance of your Y is explained by X. Okay? So if you look on what, if you look on the, on this formula here, okay, you can see exactly how it is done. So variance of Y equals to beta square variance of X plus variance of epsilon. This is something that you control. This is something you cannot control. Okay? So when you control the X, because you kind of know the X, this is kind of your predictive, this is a variable that you want to base to predict Y. So you're explaining, so this is Y randomness, okay, how much of the percentage are coming from the variance of X. So this is what is coming from the variance of X. So if you look at variance of Y and you decompose it as beta square variance of X plus var of epsilon, those two are independent, okay? The fact that you have X will not improve your prediction of epsilon. So in other words, if you remember conditional expectations, okay, if you remember conditional expectations, P epsilon conditional on X equals to the probability of epsilon. Okay, so the probability of epsilon being in a certain interval, this is your residual. The probability of epsilon being in a certain interval, okay, equals to the probability. It doesn't matter if you know X or not. X doesn't improve it, right? So conditionally, epsilon and epsilon is independent of X. So no matter what kind of information you have about X, epsilon doesn't care, okay? So you can see here that the R square explains the portion of a variance of Y which is coming from X. This is because it dominated by this term. Okay? So R square tells you how good the regression is. The higher R square, the better you are. Okay? In this case, you see that with the numbers that I cooked here, the regression is 71%. Okay? Is this clear? Or 71.2, 71.6%. From the data that I created here for X and Y. And you know, when you look on the plot, you kind of see this because you see that you have this plot here, and those guys are actually somehow they are from equal distance from the plot. Okay, so the error which is coming from all of them is more or less symmetric. So it might not be such a bad predictor. Okay. The variance of epsilon has a name. So if you look on the variance of epsilon, you want to look, so variance of epsilon is going to be sigma epsilon square. Sigma epsilon, okay, is called the standard error. Okay?
That's some kind of white noise.
Yeah, exactly. It's not some kind of white noise. It's the white noise. Okay?
So if the R square is 99%, maybe it's a dot will
exactly.
nearly be the line.
If the R square is 99%, your white noise is going to be very, very minuscule, but it's going to be still random, but the randomness is going to be small. And how do you know that it's going to be small? Because sigma epsilon, okay, is going to be very small compared to sigma y. Okay, well, it's better to talk about variances. So variance of epsilon will be small compared to variance of y. Okay, if R squared is 100%, okay, variance of epsilon is 0. There is no randomness. For example, if I'm going to change, if I will look on Z, and instead of looking on 520, I will do 10. Let's say I will do something like that. I will do 10. Say I will take X, and I'm going to multiply it by 2. So here I will take X and multiply it by 2. Let's see if this works. Something like that. And now I'm going to run. You see, it's exact. And when I look on model score, when I'm going to look on my model score, R square is going to be 1. You see? So in this case, there is no randomness.
What is the 2 stars? You just typed the 2 stars.
Okay, restart means that I'm running it again. Okay, so every time I run, look, when I'm running it, okay, you see it runs. So every time it runs, it will do restart. It's just like in RStudio. When you have RStudio, you're opening a file. Let's say this is a file, right? You're doing source and save. It runs inside the console, right? So every time it runs, it will give you new values. So Python says to you, okay, you're starting to write, to run it, yet again. Okay? Is this clear? So that's why it is called restart. This window here, you see it's called idle shell. This is basically just like the console in RStudio. So when I have a console in RStudio, I can print U, for example, it will give me the matrix, right? It is exactly the same thing here. Let's say Y predict. You see, it gives me the prediction. If I want a Z, for example, it will give me what is Z. Okay? So this window functions as, okay, it functions as the console in, for RStudio. It's exactly the same thing. But the windows here are separate, okay? The layout is a little bit different from here. Here is the layout is kind of, okay, you have the file, here you have the, whatever you have, right? But in this case, you can see that you have, that you have something little different. Okay? Is this clear? Questions?
I mean, what is a y equals 2 asterisk
It means 2
asterisk?
times x. It means 2 times x. Okay? So when you write something like that and you run it, okay? Watch, okay, so this is x and this is y. You see, so 5 times 2, 10, 15 times 2, 30, 25 times 50.
Yeah, okay.
35 times 2, 45 times 2, 55 times 10, and you're done. Okay?
Yeah, okay. And so what reshape -1 and +1 represent?
Okay, here you go. So if I do something like that, this is what you get. You're getting an array, but you want to get, you want to get a column array. So you do this. Okay, reshape basically creates like a matrix. Okay, so reshape -1, 1 basically takes your array and creates a column vector. That's the idea. Okay.
Okay.
This clear?
Yes.
Good. Any questions? Okay, good. Excellent. Excellent. All right, so now what we want to do, we want to actually, so now when we know how to do regressions, elementary regressions, we want to merge it, okay, with regression, with basically bringing stuff from Yahoo. And for that, okay, you want to install the Pandas. So the Pandas are basically the workhorse for Python, okay? And you can actually use this Pandas to read directly from the web. So just like in MATLAB, in R, you have this quant mod library that I discussed with you. So the quant mod library enables you to scrape data from websites. Okay, Pandas are doing the same. Pandas are doing the same. Okay, so I'm actually importing Pandas here. I'm importing Pandas SPD, and then I'm importing Pandas data reader as web. So the Pandas data reader is a package that enables you to take stuff from the web and read it into Python. Okay. And you can just so when you do something like that, you can read about this package a little bit more. You can say pandas underscore data reader, and you can see exactly how this package works. Okay. So you can see that it's actually it's a workhorse. It's actually reads a lot of stuff. Okay. One of the stuff that it reads, it's it's a Yahoo stuff. So web data get web underscore get. So the web here is a pandas data reader. Inside it has a function called get data Yahoo. Okay. So let's run this function separately. So what I'm going to do, I'm going to create a new file. Okay. And I'm going to say import pandas. Well, I can do it here. It's fine. Well, I want to do it separately. Okay. I'm going to create import pandas data reader as web. And what I'm going to do now, I'm just going to do this. Like this. Okay. So I will save this file. Like something like that. Okay, and now I'm going to run it. Okay, so I actually brought some stuff into SPY. So if I'll type SPY, you see what I'm getting? I'm getting the data, okay, the classical Yahoo data into Python. And you can see exactly how many rows I have. I have 2789 rows, and I have 6 columns. Okay? So I can actually, for example, access the volume by typing SPY underscore volume like this. Okay, and it will give me just the volume column. If I want to adjust to get the adjusted close, I can do SPY, and then I'm going to type in adjusted close like this. Okay. If I do SPY dot head, I'm getting the names and the first, in the first 5 or 6 lines. Okay. So this is the data. This is a workhorse to download it. Okay. Now I don't need to be satisfied with only one SPY. All right, I can actually have multiple stocks. So I can say here SPY, and then I can say something else. Let's say GOOG, which is Google. Something like that. Let's see if this works. So then I'm going to do run module. Okay, so now what is SPY? SPY has this is the lines, right, for the S&P, and this is a line for Google. Okay, so if I want now to access the Google one, here's what I'm doing. SPY, then I'm going to close. I will say adjusted close. The name is first. Okay, and then I'm going to say GOOG. So this I'm going to access just Google. If I wanted to access the SPY, the volume of SPY, I would do exactly the same. I would take SPY. First, I'm going to go to the volume. And then after I went to the volume, I'm going to go to SPY. Like this. Okay? Questions? 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 Comments? Silence from the audience. So you got, okay, so let me do this. Let me take this guy and let me put it here. Now I can actually put SPY and Google in an array. I can say something like that. Let's say F equals to the array of SPY, Google, and let's say Apple. Something like that. Okay, and I'm going to replace this with F. And now I will do run module. Oops. Oh, of course. Of course. It's good to put the, you know. So now SPY contains 3 stocks. It contains SPY, Google, and Apple. So if I want to access now, if I'll do something like that, you see, it will actually yell. It will give me a mistake. So the first thing you want to do, you want to access the attribute here. Let's say you want to access, so when you do SPY.head, it will give you the attributes, volume and whatever. So you have, let's say, open. So you do SPY open. Okay, you can see that you have SPY, Google, and Apple. So the opening price of SPY on the 1st of February or 2nd of January 2009 was 90.44 002, Google was 153.723.801, and Apple was 306.67143. Okay? Is this clear? Is this clear? Silence in the audience.
Yes, clear.
Good. Mr. Andrew, good evening. It's most important, maybe the most important workshop that I will teach you. Okay, so web get data Yahoo. Okay, you also have SPYG, and now it's Google. It doesn't have data Google. So we can actually look if how to scrape the Google website. Let's see if we have Google. We should have Google. Okay, maybe not. I thought that they have Google. Okay, so this is going to be the usual one. Here, by the way, here you can see that you can actually read it directly with what they call the data reader. Okay. So let's actually try it. So we will take this and now what I'm going to do, I'm going to replace this guy with the code that I stole from the And now I'm going to run it, and let's see if it runs. Okay, so we want to have a web here probably. Let's see if this runs. Okay, something happened, right? So if I do Apple, it gives you Apple. Now, if I want to try and do something else, I can maybe probably change it to Google. Let's see if this works.
Yeah,
You
Ralph,
see, so it tells you the data source Google is not implemented.
I think
Maybe.
Google stopped supplying data. I tried to use it with Quant Mod. I think Google
What?
stopped supplying data.
Oh, really?
Yeah, I tried to use it in Quant Mod a while ago and I looked it up. I mean, this was an R, but I assume it's the same thing and you only can use Yahoo Finance for it now.
What about the other ones?
Well, you can use Fred and stuff like you just can't use Google.
Okay, what about Fred? So can you give me? So does it give the indexes from Fred with big F?
I think you just have to do source Fred.
Yeah, but the Apple is not. I don't think Apple will appear there. Will it?
No.
I don't think Fred carries. I don't think Fred carries stock data, right? Does it?
I think they carry index data, don't they?
Yeah. So let's look on the Fred and let's see index. What kind of indices they have there?
I use it for fixed income stuff.
I know that we want to use it for fixed income. So let's see if we can read it into Python. This is interesting. Let's say CPI. Yeah, but what is the ticker of this? CPI? It's not clear what is the index of this thing.
CPIAUSCL.
Okay, so let's with big let's try it. I mean, we have nothing to lose. We have nothing to lose, do we? Okay, so we will do what you say CPI and then
whatever was in brackets there on the bottom. I think it was CPIAUSCL.
Where did you see the brackets, Andrew?
Right under consumer on the title there at the very end of the title.
I see. Okay, great. So we take this,
I believe,
and we're going to put it here. And now the data source will be Fred like this. Let's see if this works. Fred is not implemented. Maybe small Fred. Oppa! Let's see, Apple. Voila, ladies and gentlemen. You see? Never lose hope. So if I want to actually, so let's do inflation here, inf. And if I want to access inf, I would do something like that probably. Oh, I need to run it first. Yes. Control S, run module. And now inf. And now I'm going to take and do this. Voila, ladies and gentlemen. You see? That's how you retrieve data from the Fred. So this is going to be the code to retrieve data from the Fred. So here I'm retrieving inflation from the 1st of January 2015 to 31st of December 2015. Of course, I could go much further. So I could say, for example, 2010, and here I will say 2020 or something like that. I do run. And now I'm going to get inflation. Voila. Okay, any questions? Is this clear? Now, if you are doing, different, does quant mode also uses, can retrieve data from the thread?
Yeah.
Okay. So from this perspective, you think Python and R are equivalent?
Yeah. R actually, yeah, I think in terms of like scraping and stuff, Python probably has more power.
I see. Okay.
I don't know.
All right.
I haven't used Python much at all, so.
It's time for you to switch.
Yeah, I agree.
Okay, so here, all right, so going back to this, for Yahoo, we have the function get data Yahoo. And for Netflix, I also have the function get data Yahoo. So here the dates are the same, of course. And now what is very good that I can actually return there is a function called percentage change that gives me the returns almost immediately. That's a beautiful thing to have. So you don't need to calculate returns yourself. You just do SPY adjusted close, percentage change, and you convert it to frames. So let's see what does it mean to convert it to frames. So we are going now to take this guy, and we're going to put into our small file that we have here. Where did I put my beautiful file here? Okay, no, no, here. Okay, so I'm now going to take, and we'll do this. So I'm now going to calculate, okay, the returns of SPY, Google, and Apple all at once. But I just want first to calculate the returns of SPY, like this. Okay, and I will, first of all, without to frame. Okay, so SPY return gives you this. Okay, if you do to frame, oh, So we will do SPY return. You see, it's actually, it's actually gives you the name here. So this to frame might be some importance. Okay? So the difference is between this SPY return, I meant. Okay, you see the NAN here, and then if you do to frame, it's much nicer. It gives you the names there. Okay? So it pushes the NAN down because the NAN doesn't have return. The first record doesn't have return, which is what you would expect. All right? Questions? No, good. All right, so now we are progressing, and now we are going to do this. So what we want to do, we want to trim the NAN. We want to trim the NAN. So we are trimming the first, we are actually doing what we are doing here. We're telling Python takes the record, not from the zero record, but from the first record. So remove the first record or the zeroth record from Python, okay, from your frame. By the way, you can do this as well if you want to write it into. Let's say you have here, and then you do here to frame. You have the SPY return, and you do to CSV. Okay, let's say to file you like this. Okay, so it tells you so what did it do? You see, it created the file UUU. Now, if you open it, you can see exactly how this file looks like. So you have the returns except of the first one, which you want to trim. So if you want to actually save those files, okay, and show them to somebody or for your internal validation, it is actually very easy to do. What you're doing here, okay, I did it in the console. You of course can do it inside the file itself. Okay, you're taking your variable and you're doing the function to a CSV and then the file name. Okay. Questions?
Professor, it looks like the same with two-frame function and without two-frame function. I don't know. Can you explain it?
No. It's not the same. Look at that. Look. If you do, look at that.
Just the bottom line is different.
I did it here to frame already, right? So if I look here without this to frame, I just look on this. Without this. So I will look on SPY RET. Do you see that this is your first NAN, right? Now watch. I will do SPY RET to CSV. And I will say III.CSV. Look.
Oh, okay. Yeah. This is a two-frame function, right?
Yeah.
Okay.
So you have an AN here. The two frame gives it a name SPY, right? If you're doing this or this, see? It added this SPY here. Wasn't there before.
Yeah. Okay. It's clear.
Good. So what we want to do, we want to remove this NAN here. Okay? So SPY return I lock 1 to like this. Okay, what it does, it tells Python remove the first record and just look on the column from 1 and on. Okay? So the function I lock so print data on iLog 3. So this is your data set, right? Okay, so it takes it helps us to select a value that belongs to a particular row or column from a set. So if you go here, we want to see ILAC 3. Okay, so you look on the third row, you see it here. So the age is 41, the education is 1, employee is 15, etc., etc. Okay, this is exactly what you have here. So within Pandas, okay, ILAC will tell you, I want to access whatever row, and then 2 dots means I want to access all the rows from 1 and beyond, right? So what is important to understand that we're actually working with, with Pandas. So Pandas have functions that override the usual arrays in Python. Okay, so it's kind of a language within a language. Okay, if you want to access more, let's say ILAC 1.3 will tell you to access the rows from 1 to 3. And here, oops, you will access all the columns, right? So the first one means you're going to access all rows, but from columns 1 to 3. So here you have all the rows, okay? Maybe I will put this article here. Like this. So ILOC, okay, is basically a function within this pandas library, okay? So inside Python, the power of Python is coming from the fact that you have all these libraries around it. Python itself is an impotent language. It's a worthless piece of shit, okay, without those libraries, which is actually not the situation for R, because in R, you have a lot of built-in functions. So you can't say that R is a piece of turd. You know, if you go and you throw all the libraries, R will still have some value because it has a lot of statistical functions. But Python without these libraries is a big pile of turd. Okay? What we want to do, we want to use these libraries, we want to learn these libraries. That's a way for us to know Python, okay? And once again, I remind you that the magic function is pip install. Unless you are working, for example, if you are working on a work on Wall Street, then you are going to have Anaconda 30 or 40 gigabyte downloaded on your machine, okay? So I'm a private user. I do not want 30 gigabyte, contaminating my machine. I don't like that at all. Okay? Is this clear? Is this clear? Cool. Good. All right. So we are here. So we cleaned our data. So we cleaned the SPY. We cleaned the Netflix. Okay. So here in this example, we download 2 stocks. We download Yahoo and Netflix, and you see we do it in 2 commands, even though we could do it in 1 command. And I'm going to show the next round how to do it with 1 command. It's actually very easy. Okay. And now I'm bringing in the regression model. Regression underscore model is linear regression. Okay, maybe I'll just, let's see, can I save this? Where did I save this file? In some crazy directory. Let me see if I can bring this file into your kingdom. This is a file. But it won't run if you want to install all these libraries. Okay. So you have y underscore predicted. Okay, so you have x. Now my x is my SPY return. My y is my Netflix return. And here I'm saying, okay, and then I'm deploying the regression model, right? So I'm saying regression model fit xy. And the y predicted is regression model predict x. So if I want to find, let's say, my slope, it is going to be, this is going to be my beta, okay? My intercept is going to be my intercept here, and my R square is going to be R2. So I have R square here. I have my mean square error, okay, which is going to be my standard error of the residual, and y predicted is going to be my my regression, okay? Okay, so you see, I plotted here my intercept is 0.0014. My slope is actually very close to 1. And my standard deviation is going to be 0.00009, whatever. Okay, remember that this is daily. So if I want to annualize, I need to multiply by square root of 365. And you can see that the R2, okay, is actually the R2 score is actually the R square is actually very low, which is 10%, which means that that Netflix doesn't have too much to do with the market. It's actually, you know, it's actually an autonomous it's an autonomous stock. Okay. Questions? Now, if I want to, you know, if I want to look, for example, for T stats or something, can I do it? Let's see if I can do it. Probably I can. So do we have the T stat here? Let's see. So the fact that I have prediction, I don't care about that because I want to find the T statistics in Python. Okay, so this is going to be another package. But I wonder if I can find this in the... okay, if you don't need detailed results and want to use approach. Okay, so stats models. So it claims that we need this to bring this package stats models in order for us to be able to get the statistics. So let's see if this works. So we want to do this. Let's see if this will work for us. Okay, so what I want to do now, I want to see if I can actually go beyond the simple regression model that I presented here. Okay, so this is a simple regression model, and what I'm going to do now, let's see if I can actually beef it a little bit. So I will do this, and I will say here, pip install stats model .api. So pip install. Let's see if I can copy paste this here. It doesn't have this. Let's see if I can with examples. Okay. All right, so this is boring. This is boring. Got you. So it does use a SM statistics, the SM. Yeah, it does use this. Maybe it stats models. Aha, all right, got you. All right, so it's the package is stats model. So what I want to do now, I'm going to take my package. Where is it? No. Here. And I want to do this. And now so we want to do this here. So we will do something like that. First, we'll add the constant. We will add it to the, I think, to SPY return. Okay, and now we will try to run the regression, but with this new guy, which is SM dot, which is SM. So we have this. Let's see if this will work. So we want to fit Y with X, fit, and then we want to do results. So let's see if this works. And this I will say X, and this is going to be X0. So results, let's see if it did something. Let's say results.summary. Oh, a beauty to behold, ladies and gentlemen, a beauty to behold. This is your T-stat, you see? So you have your T-stat for the, for the coefficient here. And the T-stat, is 18.44, which is basically very, very high to 0. Okay? Questions? And you see that the R square is 0.109. The adjusted R square is 0.108. And these two guys are what we call Akayakiki, criteria for regression fitness. Maybe we'll cover it next time, next lecture. Questions? Questions?
So what is the T? Is it the degree of
The
freedom?
T statistics, okay. If you look, you see the coefficient here, and you see the standard error. How do you calculate the T statistic? The standard error, I'm going to explain to you so the coefficient here itself is a random variable, okay? So what you want to do, you want to calculate the coefficient as a random variable, okay? The standard error of the coefficient is 0.057. So how do you calculate the T statistics? The T statistics is So this is your estimate. This is your standard error of the coefficient. So when you divide one by another, you are going to get the T statistic. So if you take 1.0528 and you divide by 0.057, you will get 18.47, which is exactly what you see here. Okay?
Yeah.
So it actually calculates it for you without, you don't need to do it. This thing is actually calculates it for you. Okay? I see what's going on. Okay, so we need a constant here. So we're going to say x0, like this.
Yeah, I was gonna ask about that.
Well, great minds think alike, right? Now you say results, the summary. So this is your constant. You see that the coefficient, which is, is basically more than 0.01, but you have a lot of stuff here as well. So you see, Ali, you have also T statistic for the, for the constant, right? But the T statistics is actually much lower. It's 2.573. So it means that you have at least 1% here, okay, where the intercept is not going to be what it is 0, but it's going to be 0. Okay?
Yeah, okay.
Now you can actually access also the coefficients from these results if you want. Somehow. Somehow. So we want to see how to access this thingy in so stats model coefficient access here. So you have the result and the result params, let's say. Mm-hmm. So print results params, let's say. So print results params. Okay. So sync, let's say, results dot constant. No. Maybe. So results dot params dot const will work. Yeah. So you can do this, right? Results dot params dot const. So let's print it. Print results dot params dot const will give you the coefficient, the intercept. And now if you do, and instead of a constant, you will put adjusted close. Should give you the yeah. Okay. So also gives you the intercept. Comments, thoughts? So I will put it here. For you to run. Absolutely, I agree with you. Okay. Questions? Comments, thoughts? Okay, so we covered the basic of regressions today in Python. So there are two models, right? So, and probably you have 10 other regression modules in R. If you want to learn a little bit more about machine learning in R, that's my favorite site. It's absolutely free. You don't need to log in, nothing. You just need to do all the, all the exercises. Okay. So it's not just regression. It's basically also other, other machine learning algorithms like K distances and all this nonsense that people are using now. Thoughts? Okay, guys, I think I'm done for today. What do you think? You learned something? So for the guys now in the spring semester, you will probably get your last project doing in Python. My personal preference is R, is still R. Okay, because the language is much more flowing, I feel more natural. But you can't argue on taste or on taste and smell. So most of the street prefers Python. So I'm not the one to tell them how to manage their portfolios. Should I use PyCharm? It's too heavy, my friend. It's too heavy. I like my idle. It's too heavy. These Anaconda's pie charms are too heavy for me. I really don't like them. That's why I'm using idle and the terminal to install packages. It's good enough for me. I'm not in the professional world. I'm a professor, so I don't need to use these tools. But this is not, if you're doing professional Python, you should use Anaconda, right? 30 gigabyte of garbage. Okay. Okay. Where you work, Andrew, you guys are using Python or R or both?
I actually had to like push and had to like talk to compliance and my manager about using R since it's like open source and stuff about like
But
downloading.
Python is also open source, so.
Yeah, no, for both. I had to talk. I was in a meeting with my manager and the programmer at my job to see if like they would put the okay on it, and then he had to go to compliance. It's bureaucracy, but
So what do you do? You do Excel?
yeah, they use because we use Morningstar Direct.
Man, I mean.
I know, and but because say if we're running like Fama French factor data, like they go and pull it from Tuck Dartmouth Fama Eugene's Fama's website, download it, format it, and that's that code that I wrote in R to just pull everything into one data frame automatically.
You learn something from Yakov. I'm proud of myself.
And that fixed income code too that I wrote.
Well, they're dinosaurs,
Yeah, there's hope though. We'll see.
We'll see. Yeah. Good luck with that. Well, they don't know that they're all about to die, so that's okay. Crypto is going to put them out of their misery.
I know. I've been holding one a long time, the third generation type of cryptocurrency.
Cardo?
Yeah, actually, exactly. You heard it? Yeah.
I'm a man of many talents.
I've held that for like 3 years.
Well, it appreciated like 10 or 20 times recently, so you've done well.
Yeah, I should have bought more at 2 cents, but hindsight's 2020.
Exactly. But at least you invested enough to make a difference?
Yeah.
Good. Now you can get a down payment for a house.
Yeah. Well, I'll wait till the eviction mandates run out and the market crashes, and then I'll get in.
Okay, good enough. You guys also should look into crypto. That's the future. It's like a gunpowder. I have a friend, he compares, crypto to gunpowder. So, you either become, you either meet the fate of the Aztecs, right? When they met Cortez, or you will start adapting to the new world and start doing crypto.
Yakov, do you know the process behind that runs smart contracts on a blockchain?
Yes, I do, of course.
Would
I'm
you
going
be
to have
willing-
we are going to have, first of all, we are going to have entire program on that next, probably in fall 2022. But yes, I know how it is done. Let's discuss it offline, okay?
Okay.
Okay, guys, do you have any other questions? Hopefully it was helpful.
Yes, it is so helpful.
Good. You need to start, start using Python slowly but surely. Okay? Because if you want to find a job, it will be easier to find a job if you know Python versus if you don't know Python. Okay, guys, I'll let you go, okay? You have the files, so you can start playing with that.
All right. Have a good weekend, Yakov.
I will. Let me take it offline with you. Okay. One moment. Okay, guys, you should have a great day. I should have a great night. So good. Have a great Saturday, because you guys are on the other side of the earth. Correct?
Have a good night, Professor.
Good night. See you around. Me too. Let me first stop recording.